You probably won't use this tool every day, but when you do need it, it can quickly provide information that would normally be difficult to get. You can use this pump to test carburetor inlet needle sealing, impulse-type fuel pumps, oil pressure switches, and other systems that require pressure or vacuum. If you encounter a chronic leaking problem with a carburetor that is not cured by a carb overhaul, there are several tests we can perform with this tool. First, we can check the inlet needle pop-off pressure. Remove the carburetor bowl and wet the inlet needle with fuel. Attach a short length of 1/4 inch fuel line to the tester and fuel inlet barb on the carburetor. Invert the carb so the float is up. With the pump set for pressure, slowly pump the handle while watching the gauge. The fuel inlet on the carburetor should hold pressure and the needle should pop off at about 8 psi. As soon as this occurs, stop pumping. If the needle pops off at less than 8 psi, the needle may not seal well, causing a chronic leak. At more than 8 psi, the engine may starve for fuel because it can't enter the carburetor well. Once the inlet needle pops off the seat, it should reseal and hold pressure at 1.5 pounds. If it does not, you may have identified the chronic leak problem. Before you replace the inlet seat or needle, we can also check for porosity in the metal of the carburetor body. Fill a bowl with water. The bowl should be big enough that the carburetor can be submerged in it. Pinch and hold the float so the inlet needle is forced against the seat. This should eliminate the seat and needle as a source of leakage. Immerse the carburetor in the water bath and apply some pressure with the pump. Look for air bubbles. If present, try to determine where they come from. Porosity can occur in the metal of the carburetor in and around the needle and seat casting, as the structure can be thinner in this area. After this test, the inlet needle or seat must be replaced. Forcing the two together will likely cause damage. Most Briggs & Stratton fuel pumps are powered by a pulsating crankcase vacuum. This is a changing pressure condition caused by the piston assemblies moving in and out of the crankcase. There are 3 parts to impulse fuel pump testing. This changing condition moves a diaphragm in and out, which causes fuel to be drawn from the fuel supply and moved to the carburetor. The measure of the crankcase vacuum is directly related to the overall health of the engine. Worn or leaking compression components will affect the movement of the pump diaphragm. If fuel delivery from the pump is low or erratic, check crankcase vacuum with a manometer or digital crankcase vacuum tester. Vacuum should be 8 to 10 inches of water. If vacuum is adequate, test the pump with the pressure vacuum pump. Do not apply more than 10 psi of pressure when testing, or the fuel pump may be damaged. Connect the pump to the pulse line fitting and hold your thumb over the fuel pump screen. Apply pressure. The pressure should hold. Apply pressure to the pulse line fitting with your thumb off the screen, and air should easily pass through the screen. If the pump fails this test, replace it. Apply pressure to the inlet line fitting while holding your thumb over the outlet line fitting. Pressure should hold. Apply pressure to the inlet line fitting with your thumb off the outlet line fitting. Air should pass through. If the pump fails this test, replace it. Apply pressure to the outlet line fitting. The pressure should hold, indicating both of the internal pump valves are good. If the pump fails this test, replace it. Many Briggs & Stratton engines feature pressure lubrication. Most of these will offer a pressure switch that will indicate if the oil pressure drops to a dangerous level. These switches can also be tested with the pressure vacuum pump. Here's how. Use a digital meter set up for a continuity test. Attach one probe to the terminal on the pressure switch. Ground the other to the switch body. At rest, there should be continuity through the switch. Attach the pump set for pressure to the switch. Slowly increase the pressure. The switch should open, indicating no continuity when the appropriate pressure is applied. Check the repair manual for the specific engine model. Pressures will vary from approximately 4.5 psi to 8 psi between engine families. You'll also find this pump useful in checking vacuum pull-offs, bleeding hydraulic brakes for ride-on equipment, and any other repair that requires graduated pressure or vacuum.